Welcome, my fellow assassins, to this programming tutorial where today we are going to be implementing a basic iOS app that utilizes binary search as well as SwiftUI to create a fairly basic app that will guess the number that we are thinking of. So I have some starter code here for this project to get us started, which I'll go through here pretty quickly just to get everyone up to speed. So first here we have this private variable called top. This is just a global variable that will be the maximum range that we can pick our number from, but this number is completely arbitrary. You could change this to be whatever you wanted it to be. Guessing, this is going to be a variable that we use to tell the UI if we are currently guessing the number or if we are selecting the range for our number. Correct alert, this is pretty self-explanatory. If the AI guesses correctly, this will be set to true and it'll display the proper alert. Similarly, for invalid range, if our range is invalid, it will display an alert. Same thing with liar alert. If the AI detects that we are lying about the number that we guessed, it will display another alert. And then we have our previous guess, the current guess of the AI, and then the top and the bottom ranges. So that is it for this file. And then, of course, in the brain.swift file here, this is where we're going to implement the actual brains of the AI and how it's going to guess, which is where we will do the binary search. But before we get into that, let's create some of the user interface here. So we have the title, of course, here, which is just number guessing AI. Of course, you could change that to be whatever you wanted it to be. But first, let us use that guessing feature. So what we can do is, if we are not currently guessing, what we want to do is we want to implement the UI for selecting the range of values to guess from. So first we will do text, and then we'll just do guess range, just like that. And then what we want to do is we want to format things so we can do a, let's see here. Let's do an H stack just so everything's lined up in a row, and then we can do another text. And then what we can do is we can do text to signify what our range is going to be. So in this case, we're always going to start with 0, but again, you could change that to be whatever you wanted to, and you could, of course, create another global variable for the bottom to be whatever the bottom range is. But just for the sake of this tutorial, I'm just going to hard code it as 0. And then we can implement a slider, and this will give us the kind of the range that we want to do. Or use rather. So what we can do here is we have to give the value, the kind of the increment, and then the steps. So the value is going to be our bottom range. So we specify that with the $, bottom range. And then the next value that we want to add is the in, which is going to be the bottom to the top. So in our case, we're just hard coding this as 0. And then ... and then top. And then finally, what is our step going to be? So this is kind of arbitrary. This is basically what step, every time you kind of move the slider here, every time you move it up, like how much does it increment by? So in this case, what I'm just going to do is I'm going to do step is top divided by 20. And essentially what that's just going to do is it's going to increment by 5 since our top of the range is 100. So once we get that, we can do another text just to show what the end is. So we can do something like this, and that will signify the top. But of course we want that to be an integer, so we can do int top, just like so. And then we can add some additional padding to the H stack just to make it look a little bit nicer. And that looks pretty good to me. So actually, let's add a spacer here. just to give a little space. All right, and next, oh, don't want that. Next, we have to essentially do the same thing for the bottom range. So what I'm going to do is I'm just going to copy this H stack here and then just paste it, and then change all these lowers to uppers. So upper bound, and then this of course is going to be top range, and yep, that looks good to me. So the next thing we want to do is we want to let the user know what their current range is. So what we can do for that is below this H stack here, we can create some text, and what we can do is we can do int bottom range, and then actually we need another, there we go, int top range, just like that. So now that we have that, we can set the color of this. So what I'm going to do is I'm going to do foreground color, and what I'm going to do is I'm going to set it equal to blue if it's valid and red if it's invalid. So the way I'm going to do that is first convert each of these guys to integers and do what's called a tertiary operator. So I'm just going to do int bottom range, if that's less than or equal to int top range, and if that's true, what we're going to do is we're going to do blue, otherwise we're going to do red. And then the last thing I'll do is I'll just add some additional padding here. All right, so if we do that, so now what we should see is if we move the lower range to a value greater than the upper range, it'll go red, which we see right there. So that's working good. So the next thing we want to do is we need to add a button to actually, tell this thing to start, because right now we just have sliders that don't really do anything. So we actually need the start button to essentially kick all of this off. So to do that, I am going to add another spacer here, and then I'm going to create a button, and we're going to give it the name start, and then we'll do action, and then for the action, we are going to do just a quick if statement here. So first we want to check if our range is valid. So if bottom range is greater than top range, we know our range is invalid. So we can set invalid range to be true. If I can spell true, there we go. And then we can return. And then otherwise, we are going to be, the AI is going to be guessing, so we can set guessing equal to true. And then here we have to do make AI guess, which we will implement later. But for right now, just to get this working, we'll make an alert here, so .alert. And then we will set that to is presented to invalid range. And essentially what this is doing here is it's basically checking to see if is invalid range is true or not, and if it is, then it will display the alert. So let's see. What is this? Yeah, so we need to create an alert here. So the alert, and for the title, we will just give it invalid. Actually, we need to do text here. So text invalid range. And then for the dismiss button, we can just leave that as the default. So dismiss button, and then we can just set that to default. With the text of OK. So now Let's see, what doesn't it like here? So I just, of course, can't spell and had default spelled wrong. So now, yeah, sure. So now we got that fixed up. So now what we should be able to see is if we move this to an invalid range and we hit start, we should get that invalid range pop-up alert. So then we can click OK to dismiss it, and that's working just as we expect it to. And then of course, if we don't set it, if we hit start, that's just going to clear everything because we're guessing and we haven't implemented the guessing UI yet. So in order to do that, we need to set our else statement. So we can do else. So if we are guessing, we need to basically implement the UI for that. So first what we can do is we can create some text. We'll just call it AI's guess. And then we'll make it a little bit fancier. So we'll do font.title2, and then multi-text align leading. Yeah, that looks leading. So that'll just give some formatting to it. And then what we want to do is we want to add the buttons, which actually first, for the AI's guess here, we should actually put it in there, so that will be guess, just like that. And then we need to, we'll create another H stack here, just to make sure all the buttons line up evenly. So first we'll create a button, and it will be too low, and then it'll have the action of so we'll create another function here. We'll just do liar just to check if we're lying or not, but we will just leave that blank for now. And then essentially we need to create two additional buttons, one for it being correct and then one for it being incorrect. But after each one of these buttons, I'm just going to actually, well, first off, we should probably add the alert, so in case they did lie. So we can do alert. We can do is presented, and then the is presented value is liar alert, and then for the, get rid of this. And as far as the alert itself, we will do alert, and then we will do title, text is text, and liar. And then for the dismiss button, we will do dot cancel, so the little clear it. And then of course if the user lied, that means we're kind of at the end, so we can go back to the main screen. So that for this we can just do text, it's okay, and then for the action we can set that to be guessing equals false. So something like that. Now this code isn't like the cleanest right now, so we'll just clean this up a tiny bit here. All right, so that looks at least a little bit better. So next we will create the correct button. So to do that, we can just copy this guy right here. And actually we will add some padding here under the button, just to make sure everything looks a little bit nicer. So we can go ahead and copy the button, and then we can paste it there, and then this will be correct for the middle. Correct. And there is no, for the action, we can just set correct alert equal to true. And then for this isn't going to be liar alert, this is going to be correct alert, and then just say do it. just like that. Okay, and then we don't need, for the cancel button, use that. That can stay the same. And then the padding, so that looks good. And then we will paste that button again, and this time it's the case if we're too high. So this is too high. Action, did the user lie? That looks good. Liar alert, yep. All right, so if we start this again, and we go here and hit start. I need to hit the play button there. So if we hit start here, now we can see we have our buttons for too high, too low, correct. So of course these aren't really going to do anything right now, except new it. And that takes us back to the main screen. But the other two buttons don't do anything yet because we haven't implemented them. But first, before we go any further, let's just add another button to kind of get us out of there. So let's just add a quick quit button here. So below this H stack here, let's add a quit button. So we'll do button text. We can just do quit, and then the action is guessing is equal to false, just like so. So now if we come into here, hit start, there we can see our quit button, and then that takes us back to the kind of the main screen. So far this is looking pretty good, but of course we don't actually have any of the brains implemented yet. So in order to implement the brains, let's move over to our brains file here and kind of get into writing the brains of our AI. So first, let's create a couple variables here. So the first one, create a private variable for the lower bound, and we'll just set that to be 0 by default, and then we'll create another one. We'll call this upper for the upper bound. We'll set that to int max, just as the max value just to start with, and then we can do the same thing for the guess. So this is going to be the current guess that the AI is going to select, and we'll set that to int.min just for right now. All right, so now we need to initialize this guy. So because we want this to kind of initialize over and over again, I'm not going to create an init function specifically. I'll just create a separate function, initialize, which will basically set the values to their initial values, if you will. So to do that, we can create a public func. We'll call it initialize, and then we'll do lower, that is an int, and then upper int. Just like that. Now, if you haven't seen Swift before, basically what this underscore denotes is you don't have to specify the name of the variable. So if you go back to content view here you'll see this is presented with the colon. If we didn't have that underscore here, we would have to specify lower with the colon and then the value we want. So this just basically lets us pass in the variables without having to specify that. So in order to set these, we will do self.lower equals lower, and then self.upper is equal to upper, and then we'll just set the guess to its default value, which is int.min. So that will be our initialize function, and then we need to do the guess function, which is where we're going to actually implement the binary search. But before we get into implementing it, let's first go over how the binary search actually works. All right, so now let's talk about how the binary search algorithm works. So let's assume you have the following array of data here. Now it's important to note that for binary search to work properly, you need to ensure that all of your data is sorted, in this case, in ascending order. Now, for our case, our use case, this is already going to be guaranteed since we're guessing between a range of a lower bound and an upper bound, so we're guaranteed to have all the numbers in order. But for an example of how you would search through this array to find the number you're looking for, let's first go through what the intuitive solution would be, which is a linear search. So for instance, if you were trying to find the value 73 here, what you would do in a linear search is you would start at the first index, which is 4, and then you would basically iterate, checking each value to see if it is equal to 73. And as we'll see, none of these values are equal to 73 until we actually get to 73, in which case we found our value. Now, it's a little bit different with binary search, because how binary search works is, so if again we're looking for 73, binary search will start in the middle. So in this case, I'll say the middle is about, we'll go with 36. So what binary search does is it starts here at 36, and then it compares 36 to the number we're looking for. In this case, 73 is larger than 36, so we know that 36 is now our new lower bound value, so we can essentially remove all of these values to the left here. So then what we need to do is we then find the next midpoint, which in this case looks to be about 68. So 68, of course, is still less than 73. So in that case, that is our new lower bound, and we can remove all of this stuff below 68. So then we find the next midpoint, which in this case is 76, and here we see 76 is greater than 73, so we can so that is our new upper bound, and everything above 76 we can remove. And then of course the next midpoint is indeed 73, and we have found our value. So that was what, 1, 2, 3, 4 searches, so 4 iterations rather than having to go through all of these values to find 73. So the binary search is definitely much more efficient than doing a linear search, and it can give the appearance that you have intelligence because you are honing in and narrowing in on that value you are searching for. So that's a brief overview of binary search. Now let's implement it. So now that we've gone over how the binary search actually works, let's get into making an implementation of it. Now, of course, this isn't going to be any kind of a loop type of a deal, because the looping portion will actually be handled in the main driver code here, where we select whether the guess was too high or too low, and that'll kind of be the looping function for us. So first, what we should do is let's create another function here. We'll call it make guess. And this is going to take in the previous result, and we're going to create a guess result, which we'll implement in a little bit here. And then this, of course, will return an integer. So let's create this guess result. So this is just going to be an enum. So we can do enum guess result. There we go. And then, so this is going to be, so the first value is going to be if the guess was too high. So guess result high. And then the next one is going to be low. So guess low. And then the last one is if there hasn't been a guess yet. So case guess result NA. Alright, so that looks good. And then of course this is getting mad because we aren't returning anything. So we will just do return guess just to make it happy. So that's going to be kind of the default case. So first what we should do is we want to check if the guess result, we want to figure out what the previous result was. So to do that, what we can do is we can create a switch statement here, and we're going to be switching on the value previous result. So the first case here, of course, is going to be guess result high. And then, so here we're going to implement some code, and then of course the next one we will have guess result low, and then the default case is if we haven't given a guess yet. So now to implement these. So for the default case, we're just going to break since there's nothing to do. As far as if the guess is too high, so as we'll recall from when we discussed how the binary search works, if the guess is too high, that means that that is our new upper bound. So whatever the previous upper bound was, we know that that's obviously even higher, so that is no longer the upper bound, so the new value is the upper bound. So if the guess is too high, what we can do is we can set upper equal to the current guess. And then similarly, if the guess was too low, we know that that is our new lower bound value, so we can set lower equal to the guess. And then of course we need to add breaks here so we don't fall through and run the other parts of the switch statement. So now that we have our switch statement done here, let me format this a little bit. There we go. Now that we have the switch statement here, we actually need to do the algorithm, if you will, in order to get our new guess. So in order to get the new guess, what we have to do is we have to find that median value. So in order to do that, we'll do guess is equal to the lower value plus the upper value minus the lower value, and then divided by 2. And this will give us what the middle is. So find midpoint. And then of course we want to return that as our guess. So with that implemented, let's head on back to the content view here and get this AI actually implemented into the code. So first, back up at the top here, let's create a new variable. We'll call it AI, and that is equal to AI. So just using the default constructor there, so that'll create our AI. And then what we want to do is we want to initialize it whenever we run this start function. So this make AI guess here, we can actually implement this. So what that is going to look like is we're going to want to call that initialize function. So AI.initialize, and then this is going to be equal to the lower, which is the bottom range, and then of course the upper is the top range, just like that. And then of course one thing I should mention is because of how bounds work in this, we just have to do a +1 in order to ensure that we get whatever the top value of our range is. So then guess is equal to AI.make guess, and the previous result, there was no previous result, so in this case we'll do NA. So just like that. So now that we have that working, now we need to actually have the AI guess each time it comes through this loop. So in order to do that, let's implement that that liar function that I kind of touched on before. So to do that, let's go down here to the bottom, and right here we'll create a private function. We'll call it liar. And this is going to take in the result because we're going to pass this into the make guess function. So we'll just call this res, and this is a guess result. So what we're first going to want to do is we're going to set the previous value equal to the current guess. And then we're going to update the guess to the AI's guess. So AI.make guess, and then we'll pass it the result. And then we want to check if the user is lying or not. So in order to do that, what we can do is we can set liar alert equal to the if previous is equal to the guess. Because if the previous is equal to the guess, that means that the user lied because we have gotten to the very end of the binary search and the user said that that value isn't what they were thinking of, meaning that they lied. Yeah, so the reason for this is I just put this in the wrong spots. We will cut that and, nope, not there. There we go. Now that'll work. All right, so now getting up here, did the user lie? So here we can just call the liar function and then pass it the result. So this is too high, so this is going to be guess result high. And then up here, this is too low, so here we can do guess result low. just like that. All right, so now let's give this a test now that we've kind of implemented everything just to make sure that everything works. So let's set the range to be 30 and 70. So I'm going to guess, I'm going to think of the number 45. So let's give this a start. 50 is obviously higher than 45, too high. 40 is too low. 45, oh, it got it right on the money, so that is correct. All right, let's give an instance where I'm lying. So this time we'll change the range to be 30 and 90, but I'm going to be devious, and my number is 15, so I'm lying about the range. So 60, of course, that's too high. 45, that's too high. 37's too high. Same with 33. Same with 31. Same with 30. Of course, I'm a liar because we got through the entire range and I said it never found the number, which of course is not true. So that is working pretty great. So yeah, that was the development of a SwiftUI app that implements the binary search algorithm to give an AI-like implementation for your phone in this case to guess what number you are thinking of. So if you enjoyed this video or if you learned something, be sure to give it a like and subscribe to the channel for more programming tutorials. And if you have any recommendations for future tutorials or any comments or questions about this tutorial, definitely be sure to let me know down in the comments below. And I will also try to make sure that I post a link to this on my GitHub just so if you want to look at the source code directly, you can do that as well. So thank you all for watching, and I will see you in the next one.